The humble shoelace can actually explode with the force of a small bomb when heated. This astonishing power comes from the very materials used to craft its seemingly simple fibers. Most modern shoelaces are made from synthetic polymers, which possess unique chemical properties when subjected to heat. Understanding these properties unlocks a fascinating world of cooking chemistry and material science. Think about how heat transforms everyday ingredients into delicious meals on your stove. The same principles apply when a shoelace goes from flexible string to a potential projectile. It's a dramatic example of energy transfer and molecular change happening right before your eyes. This phenomenon is primarily driven by the rapid expansion of trapped air within the polymer structure. Polymers like nylon and polyester are essentially long chains of molecules, creating a complex, interwoven matrix. When you heat a shoelace, these molecules begin to vibrate more vigorously, increasing their kinetic energy. This energy transfer causes the air pockets trapped within the fiber's core to expand dramatically. Imagine a balloon being rapidly inflated inside a confined space. That's essentially what happens to the air. The polymer fibers themselves also begin to soften and melt at high temperatures, losing their structural integrity. This combination of expanding air and weakening material creates immense internal pressure. But that's not the strangest part of this explosive reaction. The rapid release of this pent-up pressure causes the shoelace to snap or even shatter violently. It's akin to a tiny, contained explosion, sending fragments flying outwards with surprising speed. The specific outcome depends on the lace's material, its tightness, and the rate of heating. For instance, a tightly woven lace might create more pressure before failing catastrophically. This principle of thermal expansion is not just about exploding shoelaces. It's fundamental to many processes. It explains why bridges need expansion joints to prevent buckling in summer heat. It's also why popcorn kernels burst open when heated, releasing their starchy insides. Even the way your oven cooks food relies on controlled heat transfer and molecular changes. Wait until you hear what comes next regarding common kitchen mishaps. Accidentally burning food can create similar, though less dramatic, pressure buildups within the food's structure. The carbonization process releases gases that can cause bubbling or even charring to expand rapidly. This understanding helps us appreciate the precise control needed in culinary arts and industrial manufacturing. It's the science behind making that perfect crust or ensuring materials withstand extreme conditions. The explosive shoelace serves as an extreme, memorable illustration of these everyday scientific principles. It shows how materials we take for granted behave under stress and heat. Every day, and then something unexpected happened. When scientists began studying this effect more closely, they realized these principles could be applied to create safer, more efficient materials. For example, understanding polymer behavior leads to better protective gear and advanced textiles. The science of heat and expansion is crucial for designing everything from aircraft engines to cooking pots. It highlights the interconnectedness of seemingly unrelated scientific fields. The chemistry happening within that shoelace is a microcosm of larger physical laws at play. It reminds us that even the most mundane objects hold extraordinary scientific secrets. This phenomenon underscores the importance of studying material science for innovation. It's about harnessing energy and understanding molecular interactions for practical applications. The forces at play are immense, even on a small scale. It's a testament to the power hidden within everyday materials, waiting to be understood.
This scientific insight can be applied to creating stronger, more durable products.
More durable. How much products chemistry is involved in simple things like tying your shoes. The same principles of expansion and pressure are seen in many cooking techniques. Think about how steam builds up inside a pressure cooker for faster cooking. That stored energy is released when the valve opens, cooking food rapidly. Similarly, the rapid heating of a shoelace causes a swift release of energy. The physics of breaking bonds and molecular rearrangement are key. It's about understanding the point at which a material's structure will fail. This knowledge allows for the creation of materials that withstand specific stresses. It's the difference between a successful experiment and a dangerous mishap.
The exploding shoelace is a vivid, albeit extreme, example of this.
It's a powerful demonstration of thermodynamics in action. Understanding these concepts enhances our appreciation for the world around us. It shows how science is woven into the fabric of our daily lives. This deep dive into shoelace physics reveals universal scientific truths. It's a reminder that curiosity can lead to profound discoveries. If you found this explosive science as fascinating as we did, subscribe for more incredible stories like this. Let us know in the comments what everyday objects hidden science you'd like us to explore next. Your engagement helps us uncover more amazing discoveries. Subscribe to explore more amazing discoveries, and let me know in the comments what fascinates you most.